All right, we are going to be looking at lesson 12.2, solving problems with right triangles. This is the exact same content from section 12.1 using SOHCAHTOA, sine, cosine, and tangent functions to solve for missing sides or missing angles. And so since this is the same content, what you're going to do is you're going to try each problem and answer each question. All right, question 1, I'll get us started, and then the rest are going to be up to you. A plane flying at 31,000 feet begins a descent. So 31,000 would be on this side because that's how tall it is in the air or high it up. And descent at 660,000 feet from the airport. That's going to be land measurement. All right, find the angle of depression. So the angle of depression is looking downward. So technically we're finding this angle here, but with our lines being parallel, both the direction of the plane and the ground, we have alternate interior angles that are congruent. So right down here, that would be our missing angle we're looking for. So I'm going to label the sides. I can see that this one is opposite from the angle. And then again, we're assuming this is a right triangle. And then I can see that the angle is next to the 660,000, so that would be adjacent. Since this is missing its angle, this is going to be an inverse trig function. We have tangent of our angle equals the opposite over the adjacent. Do my t-chart. I'm going to do the inverse tangent. Those tangents are going to cancel. My angle measurement's going to drop down, and then I need to apply the inverse tangent of 31,000 divided by 660,000 on my calculator. Oops, I had to grab my calculator quick. All right, again, if you're not getting the right answers, but you're typing in the calculator information correctly, again, it could be just because your calculator is set up in a different mode than you need it to be. So double check that you're getting the correct answers. And if I do the inverse tangent of 31,000 divided by 660,000, I get an angle measurement of about... Okay, now this is a really small number, which seems really weird, 2.7 degrees. So if you're rounding this to the nearest whole number, that would be about 3 degrees. Now, that makes sense because a plane is not going to do a nosedive. So even though it's a really small number, it does make sense for this problem. All right, the rest of these word problems are actually up to you. So I'm going to zoom into each one. You're going to try it. You're going to answer the question. Make sure that you're getting them correct. And if not, you can see the answer key. All right, here is question 2. This one's a little bit tricky because this is the part you are solving for originally, but we're looking for at the end, how tall is the building? Since Juanita's height would transfer over here, you're going to take whatever your x value is at the end plus that 5, and that's going to be the height of the building. Oops, building. All right, pause it and give it a try. All right, question 3, 20-foot ladder. That's the part that's leaning. The angle of elevation against the ground there up to the wall is 50, and we're looking for x, the distance from the base of the ladder to the wall. All right, solve for number 3. Number 4, this one's another tricky one because Dennis's height will transfer over here. And so then when you look for the height of x, to find the height of the rocket, you're going to take x plus your 5, and that'll get your rocket height at the end. Rocket. Give it a try. Okay, number 5, water slide, 40-degree angle with the surface of the water. So imagine this is the water here. This would be the 40 degree. The slide is 11.5 meters high, so that would be over here 11.5. And you're looking for the length of the slide itself, which is right along here. Give that one a try. Okay, number 6. The garage is 8 feet above the street level. The driveway from the street to the garage is 45 feet long. Find the angle of incline. So that's right here. I'm just going to draw this picture a little bit bigger so you can see this would be your angle, and you'd have 8 and 45. And again, all of these we're assuming are right triangles. So go ahead and solve for that one. All right, number 7. Tower is 18 meters high, casts a shadow. So this down here is the shadow on the ground, 9.5 meters long. What's the angle of elevation to the sun? So that would be this measurement here. Give that one a try. All right, number 8 doesn't have a picture, so I'll give you a visual here. It says persons on top of a building. So I'm going to draw a building. 38-degree angle of depression to the head of the assistant. So we've got an assistant down here. So from the top of the building down to the head of the assistant. Now the angle of depression is actually this guy. But remember, if we put in that parallel line, that would also be the angle inside the triangle. Here's our 90 degrees. The assistant is 1.7 meters tall and 10 meters from the building, which means that bottom of that triangle is 10 meters. So we're trying to find the height of the building, but first we need to find the height of the triangle, and then that 1.7 from the assistant would add on to that. So you're going to be taking whatever your x value comes out to be plus 1.7 to get the height of the building. All right, number 9. Base of a 24-foot ladder is placed 8 feet from the building. Okay, here's a building. Ladder's going to lean up. It's 24 feet, and it's 8 feet from the building. This is definitely not drawn to scale. And we are looking for the angle that it makes with the ground. So that would be this angle over here. Now, once you find out the angle, you could use that angle for the next question, or you could just physically use the Pythagorean theorem. So it's just asking for how high above the ground is the top of the ladder. Well, since we have 2 of the side lengths, we could just do Pythagorean theorem on that next part. All right, number 10. A rectangle, all right, rectangle is 17 centimeters by 26. It says find the angle made by the longer side of the rectangle and the diagonal. So if I draw in the diagonal, the longer side is the 26. So I'm looking for this angle measurement right here. So essentially, I could cancel out all of this and just look at it as a triangle. All right, give that one a try. All right, and that sums up everything from this section. So hopefully you've learned a lot, and with your formative assessment, you'll be able to solve the rest of the problems. Again, make sure you're writing these down because it's pretty tough to solve these correctly without doing some work.